Hey guys, we're gonna get started. Let's take a look at the table of contents here. So far we've covered, the intro to basic commands, scripting, Python, services, and some additional commands and tools, tasks scheduling with cron. And then this week we are going to cover network packets, so more on the network side. Scapy is a library in Python. All right. Um, so just remind you that we have exam one a week from today, basically. Okay. So make sure to prepare for that. The exam is going to be close notes, but you're allowed your cheat sheet. You can expect commands, definitions. Yeah, go ahead.
How big is the cheat sheet? Lots of.
One of these, both sides is fine. Whatever you want to write on it. Yeah.
You said it's like a multiple choice type.
It's not multiple choice at all. Oh, I didn't say it. Never. So it's an essay type or scripting or commands. So it'll be about 10 questions. Make sense? So yeah, so that's kind of the idea. If you get a command, like 80% there is fine. I'm not looking for perfect syntax, but I want you to understand kind of the basic ideas. Okay. Access control is important and key. So I remind you there could be a whole bunch of problems. Got it? All right. Yeah, so great. So today we're going to look at another library, Scapy basically. So we can take a look at that here. Uh, so there's a lot of material that we can take a look. I'll just do examples basically. This one is Python scripts again, uh, but yeah, it should be fine. So some of the links. So this is called network packets in Scapy, right? So the idea is, you guys will be doing a lot of cybersecurity stuff and network security courses. So you have to have some background on, how to get packets, manipulate them. So this library actually is extremely powerful. You can do attacks as well as defense with it. And so that's the idea. So obviously, yeah, you could do things with it. So we're going to look at how it works, the basic framework. This usually I have network packets and then firewalls followed. I don't know that I'll cover both this week. There will be a lab, obviously. And firewalls, I think, probably down here somewhere. Or not. Where's firewall? Maybe I have it integrated in another module. We'll see. It's fine. All right, so let's take a look. So the idea, you guys have taken courses on networking, obviously, and you know all the principles behind, IPs and everything like that. So that's not what I'm going to cover. Instead, I assume you guys know that, and we're just going to use things. So provided here, the Scapy link, so you can go ahead and read through that, the documentation. It'll give you all the insights. And of course, there's lots of examples here. So I encourage you to read through them, okay? And obviously it talks about what we're doing is packets, okay? So just like you did network packets in your courses before, and you learn about the headers and you learn about the fields and all that. So that information comes in, but as we are constructing them, etc. So Python, this will be very straightforward to create them. And then we'll create a few problems that we can solve and implement. So let me close that. So that's the link. Go back to the table of contents. All right. And the next one, so Scapy Basics. You can see I have a Word document here. I'll go through this one today. It's kind of my demo of how things work, and we'll do some fun, interesting things with creating packets, show you how a denial of service attack would work, and also how to capture packets. Very similar to Wireshark, but here, which gives you way more flexibility because you capture the packets and then you decide what you're going to do with them. All right, so we'll go over that. Not sure that, yeah, I'll create some problems for this if I need to. All right, go back to table of contents. Sniffing and spoofing. So this is just a gives you an idea of labs in network security. So it's not, we're not going to do this lab exactly, but you can read through it. And it just has more information for you to understand how to install Scapy if it's not installed on your system. So for instance, here you can see we can do install Scapy pip, or we can figure it out. So there is a script. I'll do these, of course, I'll demo all this, but this just provides the basic functionality. So this lab is called sniffing and spoofing, and actually in network security, those are the key terms. Sniffing just means, like on the defense side, I would say mostly capturing the packets. Spoofing would be the term that's associated with attacks, right? So you spoof a packet. So anytime that you grab a packet and you send it out and you did it, I would argue it's probably an anomaly. So in that case, it's probably more related to an attack than normal behavior. Okay. So we'll take a look at that. And so the idea is just to have a good understanding of the library, but you can read through it. As I said, we're not doing this particular lab as is. So just read the information. But you will do something like this in other courses, such as network security. And then Scapy trace route. So this is a problem I've assigned in the past, and so we'll see at the end of class if I assign this one or if I create another one. All right. So just that's essentially the module for today at least. So you can see, go back to the table of contents. All right, so these are the materials. I haven't created the homework yet. And then we got exam one, and then the next topic would be account management. I'm not sure if we'll do that, probably not this Thursday. But the topics that are coming up is account management. It'll be after the exam. DNS is a tough one, so I will say the following. This is not a homework, but in about 2 weeks or so, we'll start doing slightly harder labs that involve two virtual machines instead of one. So if you remember at the beginning of the semester, I said, believe it or not, we're starting to talk about week 7 at this point, right? So start thinking about creating a second VM. Okay, just follow the instructions. As I said, keep in mind they should have different MAC addresses, right? So create a clone, but start working on that so that we can, and I think I have two VMs on my environment. So let me see that. Starting, so you see I have two VMs. So you'll start one and then you'll have a clone of the same one, but you need to be able to have different IPs on these machines so that from one machine we can ping the other. Does that make sense? So we'll start doing these types of labs coming up, especially with the DNS lab. It should make sense. What are we going to do? We're going to configure something a little bit harder, although it's not difficult to configure. But we're going to configure bind 9, which is a DNS server. And so now you're going to have a DNS client interacting with DNS server. Okay, so make sure, again, to start working on creating your second virtual machine clone. Any questions about that, guys? And that's going to be after the exam. So you saw the lab. All right, so great. So today I'm just going to open up the virtual machine here, and we're going to start going through Scapy, setting up the library, and doing a few examples. What is sniffing? What is spoofing? And I will demo those ideas. So the trace route is assigned, comes from a case that I have, so get that. All right, so start your VM and follow along and let me know if you're having issues. Yes, please.
Is this going to be the same lab that we submit for points this week or no?
The Word document that's
Yeah.
on there? It's probably that lab, but I haven't created like the problems. So the trace route might be something I demo in class and I finish it or I assign it to you guys. And then I want to at least create a one problem. But yeah, it would be, you're right. It would be those the sequence of commands on the Word document. All right, so let's go ahead and okay. So let's open up the terminal. You can see it. Down into the desktop. And DS372 underscore spring 25. All right, clear. Slash down. Yeah, so let's let's put this under network. I'm going to do a folder. Network. Scapy. Okay. So let's go in now. Network. Scapy. All right, so let's think about this. So usually when I want to test a library, I just do something like that, Python, get the Python interpreter, and then for me it should be something like import Scapy. Okay, I have it. So when you guys do this, is it already there? So you're all using the CVM, and that's why I asked because the CVM may already have it. I don't know the latest version.
I had to install one.
You had to install yours. Everyone had to install theirs. Okay, what did you guys do? Pip or app? Pip 3?
No.
Oh, you did that one, sudo apt-get. Okay, great. So sudo apt-get. So, all right, so let's do that. So you did sudo apt, whoops, apt-get install, and then just Scapy. Python 3 dash Scapy. Is that how it was on the document? So, all right. For those of you that don't have it, can you try this? Sudo apt-get install Python 3 Scapy, and it works. Everyone over here? All right, good. All right, great. So once you have that, perfect. So that's all we need. As I said, a very powerful library, and now we can start playing with it. So let's go ahead. An example. So I have these examples already on the GitHub as well. So go there. All right. So if you guys go, of course, to the repo, open up a browser here. All right, and go to repo. It should be this one, Unix and Python scripting. And it should be under UFW and Scapy. So UFW is the uncomplicated firewall of Linux, the interface to IP tables. And so you can see here are some of the examples I have. Example 1, example 2, example 3. So you just get the code from it. All right, this is what I'm going to be playing with today. All right, so let's go ahead and go back to the terminal now. So I'm going to start with example 1. Just a packet, essentially, nothing much. You can so all of these libraries are built on a C++ library called a PCAP library. Everything is built on top of that. Wireshark, TCP dump even. So all of them are built on top of this library. But instead of coding in C, you code it here in Python, and this library makes it really easy. So I'm going to create our first example. I'm going to call it example 1, .py. All right, and we can essentially just do from Scapy all import all. Okay, so in Python, you select the library, and then you say from this library, I want to import all these libraries essentially. So I'm going to test to make sure it works. So I'm going to do, so you guys have Python 3. Took a minute there, right? So, but it finished, right? So that tells us that it works, that we were able to load it. So what do we know about packets? So you guys know this already. A packet has Ethernet header, IP header, and then it might be followed by an ICMP header or a TCP header or a UDP header. If it's TCP, it will also have a payload header, right? So we have to, you can think of it as essentially as an array, called a buffer in memory, but it's an array from 0 to however long it's supposed to be. And you can think of the first 24 bytes as one header, the next 48 bytes, another header, and so on. Right? So that's essentially the idea. So we can break this down into individual headers, for instance. But one really nice feature about Scapy is that it fills in a lot of the parts of the packet by default. So you really don't have to fill in every single thing. When you instantiate a packet, it provides default values, and then you can just zero in on the header that you're trying to modify. Okay, so in this case, for instance, let's go back to the script. I'm going to create a packet A, and I'm just going to say that it's an IP packet. That's it. So you provide that information, and if that's all you provide, then it's just going to fill in the rest with default value. Super straightforward. So, and then, we can say A dot show to show the data. If we are sending things through the interface or capturing things through the interface, remember we're going to have to use the administrator privilege. All right, so let's run this one. Python 3. Let me move this down. Example 1, Python 3. There you go. As you can see, it is now a packet. It's a packet that you can send out into the network. Be careful, right? If you send 100,000 packets into the network, they will go into the network, right? And they're going to get flagged. So just, be careful with it. All right, so so we have, the different parameters that are available in an IP packet, the TTL, time to live, checksum, source IP, destination IP, and if you notice, it's just a local host for now. Does that make sense, guys? And that's a full packet. All right, good. So that's the first example, just like a hello world of Scapy, if you will. So obviously we want to send things, so let's take a look at example 2. So example 2 It's the classic sniffing example. So this, I would call this sniffing. So, anything like TCP dump that we've done in the past or Wireshark, etc. That's what this is, just capturing the packets. These things, just like with Wireshark, they have a filter associated with them. So you can plug in anything that, like Wireshark. So in Wireshark, however you can construct that filter, you can do the same here. All right, so let's create this example. I'm going to call it example 2. So I'm going to do nano example 2 dot py from Scapy dot all import all. Okay, so we do that. So now, with the way that it works is we're going to use actually a function built in Scapy called sniff. All right, so this is the function sniff, sniffing, as that is the technical term. So we have this function and it has two parameters, two arguments, I should say, that it takes. So the arguments that it takes are the filter, and also once it finds something, what does it do with that packet, right? So there's a function that will process what it captures. So this is going to be the filter here. So it uses the keyword filter. And then the simplest case is just to capture ICMP packets. What are ICMP packets? What are ICMP packets? What's an ICMP packet? 170. It's a ping packet, right? Ping. All right. So, so just to refresh your memory, UDP, DNS, things that you don't have like a three-way handshake, you don't really care. That is, that you make sure that the packets arrive there. TCP is like any connection like HTTP. You have the three-way handshake. You want to make sure you establish the connection, right? SSH, things like that. ICMP is the ping packet, basically, this type of to make sure that a computer is up and running, etc. Those are really the only three groups that we're going to look at. DNS, when we look at UDP, we'll use those examples. TCP is, like the most common one. A lot of the attacks are related, the variety, I would say, would be in the TCP packets. Okay. So that's filter. Let's take a look then at the next step, which is the function that processes the code that you would write to decide what you do with the packet. Do you filter it? Do you log it? Do you drop it? What do you do with it? All right. So in this case, that's going to be PRN equal, and then you just specify some function that you're going to create. So in this case, I'm just going to call it print underscore PKT. PKT being kind of like what I'm going to use to refer to a packet. This function then needs to be created. So we're just going to define the function over here. So I'm going to do define print underscore PKT. Yeah. And then, of course, it takes in as sort of an event, the actual packet. Okay. Just like that. Make sense? So obviously here, then we're going to process it. So the simplest thing is just to print out the result. So I'm just going to do 1, 2, 3, 4. And then I'm going to say PKT dot show. So building on what I did in example 1, now I'm just doing it in example 2. If you are to process this packet, you can add more code, and then that packet would be returned here. So then you can have PK like that. And that's it. Does that make sense, guys? So you use the standard sniff function with a filter to tell it which type of packet you want, because obviously there could be tons of packets in the network, right? Exactly like Wireshark, the exact idea, and then you just process it. So let's go ahead and run this one. This is going to run in the background. So we need to leave the terminal on. So I'm going to do Python 3. Python 3. Example 2, right? And if you, oh, okay. Oh, okay. What happened there? What's the error? What's the error? The user privilege, right? So it doesn't, the Linux operating system does not want to let you do something like that. A regular user certainly should not do it, but because you guys have administrator privileges, then you can escalate. So sudo, right? There we go. So now that I ran it with sudo, I have permissions to access the interface, both to listen to the network on this machine and also to shoot out packets out into the internet. All right, so we are listening to trigger. So notice that nothing is happening here, right? There is no traffic being captured, and that's because there is no ICMP traffic going on. So for me to generate ICMP traffic, I'm just going to create a new window, and then I'm just going to ping something, right? So, and essentially, you can ping outside into the internet, such as the DNS server for Google. So that's going to be ping 8.8, just like that. So we're going to now ping it. And as you saw in the background, something came up, right? So you can see I'm sending ICMP packets to Google, and then you can see that this is changing, is showing you all the information. You can see it's actually breaking it up into the headers, which is really nice. So you can see we've got Ethernet header, right? The first header that you have in a packet. Then we have our IP header, which if you notice, the source, well, these are the captured packets, I guess. So remember, some packets are going and some packets are coming, and you're not saying in which direction. So we're seeing it right now in the direction of the coming packets. They're coming to 10.0.2.4, which is probably our machine here. See, it's saying that it's an echo reply, so we actually know, echo request would be going, echo reply is coming back. And so these are the fields that you can play with to, to process the data. So, yeah. And then here, notice there's a payload, and if you notice, it's mainly hexadecimal data, right? So if an attack was coming in, for instance, this is where the SQL injection or the buffer overflow attack or whatever would be there. If it's unencrypted, that's the kind of thing you want to inspect as well. So that's the idea. Does this make sense? So, that's kind of, so just like we did an anomaly detection system with cron that was logging, I think, now we can add this functionality and do something similar just to check the traffic, look at things, see what is happening. Later on in the semester, we're going to do the geolocate lab. And in the geolocate lab, you can see where the packets are coming from by IP. So like we can map certain IP addresses to geographic locations all over the world. So then in that case, you could use this to have a map of the world, put little dots, right, of where your packets are coming from. And then if you see traffic from some place that you don't really do business with, that could be like an attack or, Trojan or whatever. So we'll do that example later semester, but of geolocation, but this just gives you the classic example of sniffing. Are there any questions on this? Pretty easy, right? All right, so I'm going to kill it now, and we can do another one to clear, and then I'll stop the ping also. Just still going. So start ping. There we go. And then with this tool, you can essentially replicate all the other networking tools that you're used to using. So I think that's why I've done traceroute in the past, because there is a command, right? Traceroute. And so you guys can simulate that with this and get it to function in a similar way. All right, so we've done example 1, example 2. Now I'm going to proceed to do example 3. Okay. I have example 3 here. And then we're going to start working through the Word doc and just kind of see what's there. All right, so this one's a little bit more complex. So in this case, what I want to do now is I'm going to create my own ICMP packet, right? So instead of doing a ping through the ping function in Linux, I'm going to actually create my own with Scapy. So let's go ahead and do that. So I'm going to do ls dash, oops, ls dash l. Oh, this is the other one. I'm going to leave this one open. But... All right, so I'm going to create example 3. Example 3 dot py. All right, I'm going to say from Scapy dot all import all, just like that. Okay. So what I need to create is a packet. So the way now, you can create all the individual headers and then concatenate them together. So that's essentially the hardest part. So what I'm going to do here, I'm going to do A equal IP. So that means I instantiate an IP header, right? And I'm just leaving it as default values right now. And then we can modify it. Then I'm going to do the next header that I want, which is going to be ICMP. You see that? So now I have an IP header and followed by an ICMP header. That's an ICMP packet. The Ethernet will just be filled in by default. And then the way that you concatenate them together is you do something like this. Oops, should be lowercase. P A and the forward slash. So the forward slash is how you can concatenate all the headers together. Later on, we can even add a payload for the data that we are carrying. Okay, so that's PAB. And now, so I can do p.show, right? Oops. P dot. All right, so let's go ahead and take a look at it. Python 3. And there we go. So we've just created the packet. Notice it's got a source and destination IP equal to the local host. It's an ICMP packet. It's got no data, basically, essentially. All right. So let's go ahead. And then we're going to do the fun thing of adding some payload to the ping packet. And we're going to take a look at that little exercise. All right. So great. So go back to the script and we're going to modify it a little bit. So we need to, what's the change that we obviously need to add? We need to tell it where to go, right? So I'm going to do I'm going to say destination, just like that. This is such a nice library. I mean, I remember in the past, I used to have to do this in C, C++, and that was not fun. So this is super nice. All right, so a.dst, right? And now let's just change this. Oops, one more 8. So that's it. That's essentially all we have to do. We don't have to, it converts everything. We just give it the IP address as a string. And now we've essentially made the packet so that we can ping the DNS server exactly like we did before. So now, if we want to look at it, we can look at it to see that the change took effect. And you can see that it is now set to 8.8.8, right? And it also, by default, if you notice, it changed this to since it's going somewhere now, right? It kind of is smart enough to know that to put this so that we can get the echo reply. Notice that this is an echo request. All these things are pretty important. When you guys do the actual network security labs in your other courses, you'll need to understand what's an echo request and echo reply so that you can understand the attacks and the defenses. All right, so now let's go ahead and send it, right? So I'm going to send it out. So I'm going to do sample 3. I'm going to comment this out. And instead, I'm going to say for I in range 1. 1, 2, 3, 4, send P. Do you see that? So that's it. So with this idea, you can send out the packet now into the network as long as you do sudo. Look at the implication of this. If you do one, you send out one packet. If you do that, you'll send all those packets, which is not something I would advise you do. Make sense? And that's a denial of, you would be trying to flood that DNS server. They will quickly block you. But that's the idea. All right, so let's just send out one. All right. So I'm gonna do Python 3. And it'll give us some information that it was sent. Oh, yeah, that's right. Keep forgetting. Gotta do sudo. And there you go. Sent one packet. So that packet has been sent. That's all. Questions? All right, so we've done 3 examples. We've created a packet. We've done sniffing, and this is actually spoofing because in this example, we are essentially crafting a packet and modifying it. If you see the moment you do that, it's not under the control of the OS, but it is, kind of an anomaly. So from here, you can create any type of attack that is network related, right? Okay, so let's see what else we have. So I have a few other examples here. The next one is kind of the adding a payload to it. So in this case, so the ping packet can be used actually to communicate, right? So if you think about it, you could send a ping anywhere in the world with some text. It's just in clear text in this case. But they would be able to read it and they can ping you back with other text, and then you would be able to read it so you can communicate. I don't know the rules on that. I know that for ham radio, you're not allowed to encrypt your radio communications. So I don't know with ping if it's an issue if you're sending encrypted text, right? So on your own, but I know in radio waves it's not allowed. All right, so let's go ahead and do that one. That's going to be, let's call it add message to ICMP. So add message to ICMP dot py. Okay. Oh, that reminds me, I'm looking for a student who might be interested in doing like a project on a protocol called the AT protocol. I don't know if you guys have heard of it, but have you heard of something called, you've heard of Twitter, right? And so all of you, I'm sure some of you even use it. Well, Twitter is a company, but they've created a Twitter protocol. So that allows you to create your own TikTok or your own Twitter but on top of this protocol. So if anyone is interested, I am looking for someone to work on that project just to kind of see how it works and build something. And so it's an interesting thing. All right, so let's go and continue. So now we're going to build this ICMP packet, but it's going to have a message in it, like a payload. Okay, so we'll do from Scapy dot all import all. Okay, so I'm going to create this, right? So, whoops, I'm going to create so the IP protocol. Then I'm going to change the destination. So it's just going to be equal to 8.8.8. So again, DNS, Google. B is going to be ICMP. That. And then now I'm going to create C, which is going to be the payload. And if you notice, it's quite simple. You just write some text. So hello world. So this is what I was saying. You could essentially communicate via ping all over the world. Create your own messaging system. So all we have to do is we take A/B/C. And now we have crafted our packet. So let's first of all look at it. So I'm going to do P.show, just like that. Right. So I'm going to do Control X, Y, enter. And then I'm going to say Python 3. C is not defined. Huh? Oh, look, I made it uppercase. Python is case sensitive. Yeah. And there it is. So notice it does the IP header, it does the ICMP header, and it's got this raw. See that there, raw. And that becomes the payload essentially that the packet is carrying. Okay. And so you're essentially sending that information across wherever you want, any destination in the world. Okay. So we're going to try to create a way of looking at this in a second. But let's just send out one packet first. So I'm going to go back to my code. That. And then we're just going to do for I in range. For I in range. And we're just going to send out one packet. Colon 1, 2, 3, 4. And send P essential. Okay. So we're going to send it out. Control X, Y, enter. Oh, yeah, permission. Sudo packet sent. All right, so now we're going to put it all together and we're going to have a sniff application and we're going to have a spoof application. And that way we can like see that, we are sending and getting information. All right, so here, this one is fine for sending. All right, so now let's use the other terminal for sniffing, right? So we can go in, actually, we already wrote the sniffing script. Clear. Oh. CD. Yes. 372 underscore spring 2020. Okay. Clear. Dash L. Work. And all right. So I think it was sniffing was probably example 2. Yeah. So why does this work? Because we are sending ICMP packets. Of course, if you were getting a lot of ICMP packets, you could modify the filter, such as saying ICMP and source equal 10.0.0.2 or something like that, so that you can actually specify which type of packet you want to capture, filter out all the other ICMP packets. So that's the power of this, right? So you can extend this to be as long as you want it to be. You just have to know the syntax that goes in it, right? So it would be something like NIP dot, what is SRC equal 10, and the IP address. Well, let's just keep it at ICMP for now. So this this one, well, they're both on the same machines. Remember this this has to be in a mode so it can listen to all traffic on the machine. All right, so I'm gonna do. So I think this should work. Control Y. So I'm going to start it. So I need to start it with sudo. So sudo Python 3 example 2, right? So I've got my sniffer. Notice this is sniffing. Now imagine that this is somewhere on the other side of the world, right? So this is in Japan, right? So you have a server in Japan. It's doing this sniffing. Maybe you're even printing to a printer so that you can just look at everything that has been printed. But anyway, you're just waiting for a message from, a colleague on the other side of the world. So you've got this sniffer going. Now they're going to send you a message. So I'm going to go to the other script. Should be this one in the back. Yeah. So this one is going to send a message and it's actually sending some information. So you can, I guess, encode it, use like it, some kind of coding mechanism. So this sends out a packet. A packet has been sent. So now we go to the other script. And there you go. See the sniffer, example 2, which is the sniffer, was waiting for some data. And the source was 10024, maybe in Chicago, whatever it was, came to you in Japan. Okay, great. And they just sent you some information. Did I write hello world? Yeah, hello world. I thought I wrote hello Google. Did I write? Oh no, I wrote hello world. Yeah. So we can change it, just to confirm. Hello, Google, OpenAI. Let's say. Hello, OpenAI. All right. So control Y. Same thing. I want to send a second message, right? So sent from Chicago. I've got my sniffer in Japan. There it is. Hello, OpenAI. And now I can do the same from here. I received a message. They're going to have their own sniffer over there. So because it's just ping, right? It's just, ping. As long as the ping can get to that server, it's fine. Like something on the web, etc. You have a web browser, essentially. A web server, Apache. So then, hello, OpenAI. So then they now receive the message. They could do the exact same thing from here, send out an ICMP packet to their sniffer with a reply. Make sense? And you can create almost like a chat, if you will, uh, like this. Anyway, so that's an example. So let's take a look at, so we've done, so the trace route, obviously, that's a little bit more detailed, but let's see what else we have. So I've done example 1, example 2, example 3. Yep. And I do have the firewall script in here. And then the trace route would be the next, so we might work on that. But let's go back to the Word document just to make sure I haven't missed anything. And then we'll go from there. So let's go to the Word doc here. So it should be this one, network packets and Scapy. So like I said, if you're, there's way more, obviously. So go to the Scapy link online, read all that documentation. There's quite a bit in there. Let's take a look at the PDF just to make sure we've covered the examples provided here. Yeah, you can read through it, set this. We did the installation. This example, let me move this up a little. All right, so we created a packet. We ran it. So we've done that one. Did something like that too, sniffing packets. So I've done this example, right? We sniffed. Remember, it's just doing the chmod here. So this is our sniffer. Okay. So this example is creating spoofing. So you can see it's spoofing. We did that one too. created a destination, an ICMP, and sent out one. So these are just the fields, something that you learn in 170, 270. So just the different fields in the headers. Yeah, so traceroute is kind of the next one. So we can discuss that one. Sniffing and then spoofing. This sounds fun. So this would be something like you're sniffing, and so so once again the idea of automation, right? So you're sniffing in the network, waiting for something to happen. When that happens, boom, you send something out. So this would be kind of if you're doing an attack, right? So you're waiting for somebody to do something like try to log in, and the second you detect that packet that's logging in, you launch your attack, whatever it is, right? So that's what sniffing and then spoofing relates to. So this is more related to attacks. Here's an example of this, as I was saying, as it used to be done in the past in C, C++. So that was fun. All right. So that's, the PCAP library is what's underneath. If you guys don't know this, Python is really essentially just an interface to C++. So a lot of the libraries all the time are just written in C and compiled in C, and we're just interfacing through Python. All right. So we did this. So this is just a C code. So you can read it if you'd like. Sniff and then spoof. One thing I will say, if you write the sniff and then spoof in C, it's going to be faster than if you write it in Python. So sometimes attacks need to be fast, right? So if you remember something in the network is happening really quickly and the Python may not be fast enough. All right, so, okay. So that's why there's another tool called NetWalks, which is a tool we'll use a little later in the semester when we're doing the DNS lab, for instance, just because that tool is written in C and it's a little bit faster. But when I have it with C, we'll have to do something. All right, so this document, I think we've covered, we've gone over. So these two are done. So now before we get to traceroute, let's just go to this other one, the Word document. Let's see what's in there and make sure that we've covered it. All right, so we have this library, ImageMagick. This is just for plotting and things like that. GraphViz also, so we can install them. It's fine. We've done Scapy already. Let's run Scapy ls function, which lists all available layers. All right, so let's do that. So let's do sudo Scapy ls. So let's list so I'm going to do Python here, and then I'm going to do import Scapy. And so it's saying ls should be a function. From Scapy. Try this. Oh, okay. Yeah, good. It does do it. I guess I need. Did it say something? Huh. Little sketch. I guess I get you. This. Oh, it's a Scapy. Okay. All right. So I see. So it's creating its own interface. Yeah. Yeah. Thank you. So ls, there we go. So it gives you everything that's there. So as you can see, it's a lot of networking related things. So definitely pretty powerful. So ls. And so let's go back to the documentation. Run Scapy ls function, which lists all available layers for creating, I guess, packets and things like that. So I rarely use this functionality, but it's good to get information. Oops. And so let's see what's in here. So DHCP, right? Familiar things. DNS. Got lots of things. ICMP information, IP header, IPv6. NetFlow. Packet, it's packets, got that layer. Radius server, SCTP, the raw that we saw. SNMP, this is a topic we will cover later. TCP, there it is. UDP, there it is. X506, I think this is wireless things. Zigbee even. Okay, and so on, right? So lots of things to play with. We're not going to cover, all of this, of course, but it shows you that you can construct a lot of different types of packets for both sniffing and spoofing with this library. All right, so okay, so let's see. We covered this. What do you see? So it can do things like TCP dump. So you can do IF. So I guess we're still in the environment. So IF config. Let me try that. So this is outside. This would be obviously here. IF config. And we can see remember that if you're trying to get the IP address of your VM, it should be this one, the one associated with interface ENP0S. Okay, let's go back to the Word doc. Find interfaces. So then it says sniff interface, and then it allows this. So this is just a way, instead of defining the function. So lambda is something, an advanced concept in Python that allows you to create this lambda notation. It's just like a one line that it's equivalent to having a function processing the data. Okay, you can see essentially here it says lambda x. X is the input, and what you do is x dot show. That's the same thing that we were doing. So that's so you can have one liner, and it just says to use the interface. So we can try that, I guess. So see, you can see I have the two greater than symbols when it's the regular terminal. So this must be the Scapy terminal. So let's go back to that. Scapy. And then it says sniff and the interface, which was kill this one. IF config. So the interface is going to be ENP0S3. Sniff iFace. ENS0. ENP0S3. All right, so that's the interface. And then I think it was the lambda notation. Yeah, PRN is going to be lambda. PRN equal lambda x, which just means the variable that's input, and then we say what we want to do with that variable. So it should be something like that. It's essentially what we did before in Python. Okay, let's take a look. Yep, PRN lambda interface. We already had the pseudo privilege, so we should be able to access the interface. And we're just going to sniff on it. So it says, what do you see? What is the value of the data you see? How could you use it? All right, so let's try it. Hit enter. Okay, so it's just sitting there. It's sniffing on that interface. So let's see if I can trigger something by doing a ping. Okay, there we go. So I did a ping, and you can see in the background that that also is working. It's sniffing in this case on the actual interface of your computer. Any questions? Okay. Yeah, please.
What did you do with the show interface?
Do you mean, so I went to, let me do clear here. I went to Scapy and then I did the whole, I wrote this one. Is that what you mean?
Above it, find interface. Is that?
Oh, how did I get the interface?
Yeah.
Yeah, so to get the interface, I went to another terminal. Let me go over here, open the second terminal. This is still right. Kill it, clear. And then if config, one of the Linux commands that gives you basically the interfaces on this machine. You just have to know. So these machines by default have something called Docker installed. So we'll talk about that later. It's about containerization, but really the actual interface of this machine is this one. So whenever you're looking for the interface, it's ENP0S3, and then here it gives you your actual IP address for this machine, 10024. So when you're doing the two machines for the DNS lab, one should say 10024, the other one should say 10025, and then you ping between them. Okay? Make sense, guys? All right, great. So I'm just going through the document, making sure I've covered everything. So we're looking at how to interact with the interface. We were able to get a packet. You can also send out a packet through this process. So SR1, this is a function in Scapy, and you just craft the ICMP packet. So let's see, you create it and then show it. What do you see? Now add your own. And then here we have another approach of showing the payload. This one we already did, 24. If you're in bridge mode, you may be able to communicate with your friend, get his or her IP, then send packets with your own payload message. On the receiving end, they can set TCP dump to listen to the message or their own sniffer. So we already did this example. We already did this one as well. We covered this last week, so you guys saw what TCP dump was. So this is similar to capture packets. So just, this is part of the lab, right? So go through these, run the commands. So let's do this one here. So TCP dump. I wonder if I can just copy it. All right, there it is. So sudo cd, TCP dump. So this is the built-in Linux sniffer. All right, it's got several parameters. The interface is not ETH1. It's going to be ENP0S3. This should be a single quote, so just make sure you set that up. To be a single quote, single quote. All right, unknown. Oh, I'm missing a letter. CMP. All right, and as you can see, it is listening on the network. Same idea, right? It's listening on the interface. We can trigger it once again. It's listening for ICMP packets. So let's go here, kill this one. Ping 8.8.8. Okay, it's pinging. Now I'm gonna go. And you can see TCP dump is once again capturing data. So this is just an example. All right. All consistent with sniffing and spoofing. I'm going to kill that as well. All right, so let's go back to the Word doc. So we have completed up to here, I would say. Trying to think here. Take a look at some. Well, let's try this. I don't know where I got this from. I don't see any A variables here. But let's try it. So I'm going to do sniffs. It says here sniffing. Sniff, collect data for a while, kill it. Then this. All right, so clear. So sudo Scapy. Okay. Sniff. Okay, so it's sniffing for a while. All right. So I'm doing this, collect data for a while, then control C, and then A equal underscore. I don't remember this. All right, I'm going to kill it. Control. It says control C. Okay. So we're still in Scapy, but we've killed the sniffer. A equal underscore. Okay, it took it. A dot and summary. I didn't generate anything, but I may not have collected anything either. So let's do it again. Sniff. This time I'm going to ping something. Okay, I'm pinging, right? So this time I am generating traffic. All right. Kill it, Control C. That. Yep, I guess, yeah. That's strange syntax, but it's it captures something, and some of it is the raw traffic, if you notice, right? So you got some ping packets in there. So obviously it's what I was pinging. So that's a way to collect data if you're using the Scapy interface itself. Any questions? Yeah, so this is a very, big tool. So we have covered, as I said, all this. Um, Communication. We did that. All right, so this one is a trace route. Let's take a look at this problem. This is a graphical view. So it says, you can do some very slick network visualization of trace routes if you install GraphViz and ImageMagick. This example is borrowed from the official Scapy documentation. So we're in Scapy. It's got a function for trace route. We trace route some websites, ports, and then we're going to try to graph this. What's the graph tell you? Try other websites. Okay, so let's try, before we install the libraries, let's just try this functionality. So I provide a list. Oh, actually, let me just copy this. Copy. So I'm going to go back here. I'm still in Scapy here. So, all right. So trace route these. Okay. Begin emission, finish sending 200 packets, begin emission, finish sending 20 packets. So, and then finish, right? So you have that information here. So this is a fancy and advanced trace route functionality, okay, of multiple sites. Now, the idea is, there's probably a lot of data in there, very confusing. So we might want to try to plot it. So let's try res.graph. Give it a second. And try to plot some of it. It says resource managing subprocess is still running. Enable trace malloc to get the object allocation trace route. It did generate for me something, although they're not really great graphs. So it's not so great. Maybe fewer, I think fewer websites might be a good idea. All right. This, so I'm going to repeat, but with just one. Just can type it then. All right, so res, comma, so we use the trace route functionality. Yeah, see that. Okay, let's just do it for one website. So I'm going to do www.lsu.edu. Okay. And then I'm going to do destination port, just one, equal port 80. Right. And then max TTL equal 20, comma, retry equal 2, it says. All right, so let's try that. Okay, so you can see basically for this trace route, it finished and it's just one server, 130.39.6220, right? So that's what it has. So now let's try to graph it. Okay. The graph was res.graph. Res.graph. Like pretty tiny, but like a very buggy software, I think. So the IP is there, 130, if you guys can see it. One 30.39. So, oh, barely can be seen. You can try other websites. Can you think of a website that might have several in the route? Maybe let's try pardon? Sorry. So let's try Syracuse. Yeah, still just one. So you'd have to find one that kind of gives you like the whole trace. Amazon.com maybe. Just kind of gives you. All right. Well, all right. So that it's just giving us one, but this is just an example of that. And then as I said, we can trace the plot, although the plot is not very impressive. Graph for this thing is like, let me just close all the, oh, there it is. So it generated the little graph. Okay. Let me close all this out. All right, let me close this one. Kind of start over. I have too many windows running things. So all terminals are closed. All right, so I'll let you guys play with it, but the idea is install these libraries, maybe do make sure you have like current versions updated. So it's ImageMagick and GraphViz. Do a trace route with this and then just show the plot basically, as I was showing. And maybe you can get a few more things in that trace route. All right, so that's kind of the example there. And so the graph tells you, all the trace route essentially. All right, so that's all the examples in the Word document. So we finished that one. Just kind of a quick example of how to do that. So the problem now is the Scapy trace route. So we just saw it essentially, right? So what does trace route show you? It shows you kind of all the hops between where you are and your final destination. That's essentially what it did. So the point of that is to kind of refresh our memories of how that works, and then to kind of try to simulate that in some way with our own code in Scapy. So Scapy trace route, as described in class, using the Python Scapy library, implement your own trace route. For more information, see the attached PDF, and it's going to be 2.3 task 1.3 trace route. So that's why I provided that document. We'll go take a look at it. List all router IPs between your VM and your destination and indicate the number of hops. Okay? Does that make sense? So that's kind of the idea. So let's read 2.3 task 1.3.